What's up, everyone? This is Dr. Jax. Today, we're going to be looking at changes in amplitude of waves. In order to do so, what you're going to see is a spring which is attached to a fixed end on the right. And on the other hand, a person is going to move the spring to create a wave. In the first example that you're going to see, we're going to be looking at wave reflection. And what you're going to see is that when waves are reflected, you'll see that the amplitude gets inverted. So what you'll see is on the way down, there is a positive amplitude, and on the way back, there is a negative amplitude of the same height, just in the opposite direction. So let's take a look at this first one. You'll notice that the spring starts at 0, which we call the principal axis, and as it bounces back, you'll see that the height of the wave stays the same in both directions. Over time, the amplitude will decrease due to friction and a loss of energy. All right, in this next example, what you're going to see is an example of constructive interference. Constructive interference means that the amplitude adds up to form a bigger wave. What you're going to see is that the person creates a first pulse, sends it down, waits for it to rebound, and then sends a second pulse in the same direction. As the waves cross paths, the amplitude adds and forms a bigger wave. This is an example of constructive interference. This next example, what you'll see is a situation where you have destructive interference. Destructive interference means the amplitude subtract to form a smaller wave as the pulse's path. What you'll see is as the first pulse is sent down, the second time that the person sends the pulse will be on opposite sides of the principal axis. And as they cross paths, the amplitude decreases. After the waves pass through, they move on as if nothing had happened and will be on opposite ends of the principal axis again.